Part B, we're asked about the inflection points of G. All we have is that G is defined as the integral of f. We have a graph of f. And we do understand that if G is the integral of f, then the graph of f is also a graph of G prime. Now, if we reach back to first semester and we're talking about inflection points, the first thing that should come to your mind is that a graph has an inflection point if it changes from concave up to concave down, or vice versa. And that happens when its second derivative changes signs. Positive, negative, negative, positive. The problem is we don't have a graph of G double prime. We have a graph of G prime. So now we have to kind of twist it up a little bit and just remind ourselves that if G prime changes from increasing to decreasing, then its derivative changes from positive to negative. If G prime changes from decreasing to increasing, its derivative, G double prime, will change from negative to positive. So if I have a graph of G prime, and I'm trying to talk about the inflection points of G, I'm looking for where G prime changes directions. That happens in one place on this graph. That happens when x equals 1. When x equals 1, G prime has gone from increasing to decreasing. So at 1, G double prime has changed from positive to negative. Now I don't need to write all that down. I just need to say it happens at x equals 1 because G prime changes from, I'm going to say, increasing to decreasing. And then you can assume that the person reading your paper knows enough calculus to know that, okay, so this kid really gets that if G prime is changing direction, G double prime is changing sign, therefore there's a change in concavity. All right? Hope that's starting to sink in. If not, 7:30, I'm here. Happy to help.